The intermediate value theorem. If a function is a polynomial function with only real coefficients, and if for real numbers a and b, the values of f of a and f of b are opposite in sign, then there exists at least one zero between a and b. In this example, we're asked to show that this function has at least one zero between -5 and -4. So the intermediate value theorem can be used to locate an interval that contains a zero. So the interval we want to look at is between -5 and -4. We want to know, is there a zero within this region? So to find out, you can either use the plug-in method or you can use synthetic division. I'm going to do both just so you can see what it looks like. I'll start with the plug-in method first, and I'm going to start by plugging in a -5, meaning I'm going to remove all the x's from the original equation and replace it with a -5. Now we're going to do the math. So I'm going to go ahead and click through it just to save time. Notice here my output is -18. Now, when I go back to plug in the -4, it needs to be a positive output. If it's not a positive output, then there's no zero between these numbers. But if there is a positive output, then yes, there is at least one zero between these two numbers. So now I'm going to plug in the -4, and again in the original equation, remove all the x's, replace it with -4. We're going to proceed with doing the math there so we can see what our output is. And we got a 7, a positive number. So because one of our outputs was negative and the other was positive, meaning opposite in sign, that by the intermediate value theorem, that proves that there is at least one zero between -4 and -5. I went ahead and graphed the function. Here's what it looks like. It has 3 zeros, and yes, there is at least one zero between -5 and -4.